All right, students, let us now go into this topic, this interesting topic called oxidation and reduction reactions, or we put it like this, redox reactions. So now, fundamentally, all chemical reactions are being classified into redox reactions and non-redox reactions. That is, redox reactions, which are reactions that involves electron transfer. That is, transfer of electrons from one substance to another substance in the reaction. While non-redox reactions are reactions that do not involve electron transfer. Do you understand? So this is it. Now, we have descriptive classification of chemical reactions. That is where we classify chemical reactions as combination reactions, displacement reactions, double displacement, decomposition, and the rest of them. That one is descriptive classification. But this one is fundamental classification. Do you understand? A reaction can either involve transfer of electrons or do not involve transfer of electrons. In redox reactions, there is a change in oxidation number of the substances involved in such reactions. Yes. What is an oxidation number? An oxidation number is the number that expresses the oxidation state of a substance, or the number that shows the oxidation state of a substance. That is it. The number that shows whether whether electrons are being gained by the substance or being lost by the substance, whether there is a gain or loss of electrons. Do you understand? And when a substance gains electrons, it is what? Negatively charged. When it loses electrons, it is what? Positively charged. Yes. Oxidation can also be defined as the addition of oxygen to a substance. When oxygen is added to a substance, like in most combustion reactions, like in all combustion reactions. Yes. Now, take for instance, when sodium is exposed to or bond in the presence of oxygen, when sodium is bond in the presence of oxygen, it will give us what? Sodium oxide. Okay? It will give us sodium oxide. You see? So it will give us sodium oxide when sodium is bond in the presence of oxygen. It gives us sodium oxide. Now, sodium is being oxidized in the process. In this process, sodium is what? Oxidized. Yes, because sodium loses electrons. That is Na is Na minus what? Electrons. Na plus. Okay? Na minus 1 electron. Okay, giving you what? Na plus. So oxygen gained electrons. So oxygen is 1 oxygen gained 2 electrons. O plus 2 electrons giving you what? O2 minus. Remember, don't worry. I will do this thing in detail. Okay? So I'm just introducing this to you guys. So now, let's know. Now you see what we have on this board. You see what we have on this board. After defining oxidation number, you go to determination of oxidation numbers. Now, in determining oxidation numbers, there are a few points you must know. The total oxidation number of a compound, that is a neutral compound, is what? 0. The total oxidation number of a charged compound, all these polyatomic ions, is equal to the charge in the what? Ion. That is, if you are trying to find the total oxidation number of this substance, it is equal to the charge on this ion. The same thing applies to this one, NH4 plus. So that's it. Now, apart from that, you see this one, the oxidation number of the more electronegative atom in a molecule or a complex ion is the same as the charge if it were a separate ion. This fact now is based on, let's say in this one, PCl5. You see this compound there, chlorine is more electronegative than what? Phosphorus. So this oxidation number remains what? Constant. The oxidation number is what? -1 in this case. Phosphorus, the oxidation number of phosphorus changes. Do you understand? Chlorine is more electronegative than phosphorus. Do you understand? So whenever there is a presence of more electronegative elements, the oxidation number of that electronegative element remains the same. It does not change. That's what this point is trying to tell you. Now, let's come to this one. They say the oxidation number of oxygen in compounds is always -2, except in peroxide, such as hydrogen peroxide. Yes, the oxidation number where it is -1. When it is bonded to fluorine, the oxidation number is +2. Do you see? When it's bonded to a more electronegative element, fluorine, the oxidation number becomes plus. It's just like oxygen is a woman, okay? Then when it encounters a more feminine woman, then it will appear like a man, just like that. Do you understand? The same thing goes to hydrogen. You know, hydrogen loses electrons, but when it is bonded to metals, which are more electropositive than it, it acts like a non-metal. Do you see it now? So let's say it is not metal enough, or let's say in terms of human being, he's not man enough. Do you understand? So this is how it is. So these are the important parts. That is other important points you need to know in finding or determining the oxidation numbers of unknown substances in compounds, okay, or in polyatomic ions. So this is, so I'm coming back for my next video. So in my next video, I will now move into details of this topic. See you guys in my next video.